Right, it's probably time to start. Okay, hello everyone. I'm Matteo Carlini, a technology manager at ARM, but in this context I'm representing the TrustedFirmware.org project, really. And together with my colleague Shebu here, we are very pleased to chair the board of the project. So we are going to present you the updates, what's happening in the TrustedFirmware.org, and specifically also on the A-class and M-class devices. So the agenda is pretty simple. Project updates, what's going on the project, and why you should care about it. Trusted Firmware A updates for the A-class devices, and then I'm going to hand over to Shebu for the M-class updates. Yes, we will have another celebration as in Vancouver. There will be feeds and cakes later on, so stay with us, and we will celebrate again. And Shebu is going to tell you why. So, what is TrustedFirmware.org? TrustedFirmware.org is an open governance community project that was announced last year, just after Connect Vancouver, mid of October, with 6 founding members rigorously in alphabetical order. So ARM, Cypress, Data.io, Google, Linaro, and Texas Instruments. And recently we have been joined by STMicro and news of today by Huawei. So we are very pleased to welcome Huawei in the project. The membership is open to everyone. The charter is public on the website. You can go and look. If you have any questions, how to join, how to contribute, which are the membership options, reach out to myself, Shebu, or Bill Fletcher that is around. So, what really is TrustedFirmware.org and why you should care? So, TrustedFirmware.org is an umbrella project that embraces the firmware that represents the foundation and the reference implementation for all ARM v7 and v8 on the A-class domain, as well as for v7 and v8 on the M-class architecture. So, it's really the reference implementation, the foundation software, specifically for PSA, the Platform Security Architecture framework for ARM-based IoT devices that ARM launched a while back. And a couple of weeks ago, there was a presentation at the Embedded World with the very first PSA-certified devices. But it's really a cross-architecture and cross-market segments project. So trusted firmware is applicable and is deployed in field in IoT device, embedded devices, automotive, edge, networking client, mobile infrastructure, up to edge. So it's really, up to cloud. So it's really deployed on all the compute ARM-based systems. It provides a reference implementation also of all the ARM specifications and standards. So all the PSCI implementation is implemented in Trusted Firmware, SCMI is implemented in Trusted Firmware, and so on and so forth. It's quick and easy, portable to all the newest cores. And on the A-class side, it's really the foundation of the TE, the Trusted Execution Environment. On the microcontrollers, it's the foundation of the corresponding secure processing environment. And why you should care about it. So that's really all about collaboration. It's really all about security through community effort and collaboration in order to cater the whole ecosystem security requirements and system requirements. It's really about having a collaborative space in which you can bring forward your own requirements and your own platforms as well. Because we are setting up an open continuous integration system and a board farm inside the project, so you may also achieve cost effectiveness, reduce maintenance costs, time to market, TCO, by having your board part of the project and included in the OpenCI that we are setting up. Skipping to the last point, so it's really about taking ownership of a piece of software that all your systems depends or will depend on. And you can contribute to the strategic direction and to the technical direction of the project. So the project has board meetings and TSC meetings. The TSC meetings will discuss all the strategic and technical directions, while the board will discuss all the high-level directions for the project. So that's already running. There are already monthly meetings going on, and all the resources are publicly available here. So there are a bunch of links, monthly status updates, all transparent, board meeting minutes, transparently here, project dashboards for TFA, TFM, and the test suite, wiki pages, and all the contact points, mailing list for all the projects. So that's a high-level view around trustedfirmware.org as a project overall. Now I'm going to go into a bit more details for the A-class side before leaving Shabu to the M-class. So what's happening on Trusted Firmware A? So this was Vancouver. If you remember, if you were there, we did some celebrations because Trusted Firmware A was 5 years old. So it was released as an open source project in October 2013. So last year it was exactly 5 years old, and we celebrated a lot. These were the numbers, and you can really see the progress from a NARM-controlled project in which only a small 20% of contributing commits were coming from the ecosystem, up to September, in which mostly 1/3 of the commits were coming from the ecosystem. So where we are now, what happened since then? So the first highlight is we released the test suite that we were using internally to validate trusted firmware against ARM specification and ARM APIs. So there is a project called TFA Test, Trusted Firmware A Test, that is released under the same umbrella. So in fact, you can see it's under the domain git.trustedfirmware.org. It's released with the same licensing terms and contribution agreements as the parent project. So it's BSD, free close. You can go and look at it already. There are already active contributions for the test suite. So it's all looking great. And stats. How are we doing with stats in the last 6 months? So this is where we were in Vancouver, as we said. This is where we are now. So you can see there is a continuous increasing number of contributions coming from the ecosystem. Almost half of the project is now contributed by our partners. And not because we are decreasing our effort as ARM, but because the partners are increasing their contributions. So there has been a dramatic increase here in the beginning of 2019 as we kicked off the project as a community project. Mostly for platform ports, but not necessarily only for platforms, also for core components of the firmware. But in terms of platforms, we are now having the incredible number of more than 30 partners platforms available upstream, seven of them only released in the past 3 to 6 months. So it's really, really going quite well, quite colorful as my t-shirt. New release, 2.1, tagged this week. It's out there. There is a blog post available on the website. Here is the content. So quickly through the architectural features that we enabled. So we finally allow the normal world, so the Linux kernel if you want, to make use of pointer authentication because it's enabled at EL3 in the firmware. We added support for a couple of 8.4 architectural features, and there is a new 8.5 security feature that basically is the Spectre variant 4 mitigation, and it's implemented on the newest ARM cores. And talking about the newest ARM cores, we are absolutely aligned as well with the Neoverse strategy that ARM is pursuing. So Trusted Firmware now implements not only the N1 and E1 cores, that was already there in the 2.0 release, it's not really a news, it's just been renamed with the official name, but we are also now supporting fully the modeling platforms, the FVP platforms based on N1 and E1, and the new N1 SDP, so the system development platform, that is going to be the new hardware test chip that ARM already announced and is going to be available pretty soon. And This is also useful for experience in C6, as if you were in the previous presentation from Tanu at ARM, this can be used. So Trusted Firmware support is already there, is already upstream. And in the 2.1 release, we also upstreamed the new core that's not officially available yet, but it's part of the Neoverse strategy. It's out there. It's a 2020 core, but since we are embracing an upstream first mindset, we already have patches available for TFA. So you can build your SoC based on these platforms. ROMlib support, this is a completion of a feature that was already available in 2.0. Dynamic configuration, again, so we finalized and completed our development around dynamic configuration for now, waiting for new requirements to come in. The feature is called Position Independent Executable. If you want to know more, come on Friday. There is a session in the morning where Sobi, our tech lead that is sitting down there, will present and talk through all about this feature. And then we are always trying to stay up to date with all the security vulnerabilities, and we provide mitigation as soon as we are notified of a new security vulnerability. This is the release. What's going on these months? So we are working on extending the use of pointer authentication in the secure world. So you may enable that at EL3 and also for secure OSs or trusted OSs. That's still an experimental feature on the master branch. We are still working on that. We are going to add support for branch target identifier 8.5 at EL3 as well. And we are working on a set of platform security requirements. So looking at a platform view, not really only at a component view, but topics like how to do attestation starting from the secure firmware, how to do measure boot and interact with discrete or firmware TPM on your system. So which are the APIs that Trusted Firmware is going to implement and to expose to the lower exception levels to do so. How to sign differently in the secure world different pieces of software, since the secure world is becoming to get a bit more populated with services running in secure partitions. What if they are signed differently? How the trusted boot story will look like? Dynamic configuration improvements, again, come on Friday. So these are all set of new high-level requirements that we are considering, so abstracting a bit just from a component EL3 point of view, but looking at the whole secure world story, how this will evolve in the future. Investigations are also ongoing in the area of PSA for the IoT. So PSA IoT is a thing already on the M class, and Shebu will tell everything about that. On the A class, we are start to define and really write down the requirements into Trusted Firmware and into the secure world in general to support PSA for IoT. Debug certificates and how to connect ARM debug IPs is another area that we are investing on. And we are also considering and trying to define which could be the functional safety requirements for EL3 Trusted Firmware. Migration plans, Trusted Firmware up to last week was still on GitHub, but is migrating this week, really. After the 2.1 release was the goal, so we are already there. There will be a big switch at some point, so you will see a big fat warning appearing on GitHub these days that will redirect everything to Git and Garage, to the new infrastructure under trustedfirmware.org. So this will migrate all the code base and all the review system. All the reviews will be open and transparent on Garrett, and everyone can contribute and provide feedback. Next steps are on the public CI. As I said, we are building an open CI system, opening up all the continuous build, so you will see results on the compilation against every board that we are building against. Continuous testing, initially on the models, FVP models, and moving on a Lava board farm that can embrace all the partner platforms as well in the open under the umbrella of the project. So that's almost it. Oh wait, did I forget something? What is the SPM? So we did a lot of noise in the past talking about the Secure Partition Manager. I also spoke about, okay, we are doing a lot of work in secure partitions, but where are we going with the Secure Partition Manager? Because that is something that our partners are asking a lot, also in the context of the project. So I have a big picture, but I encourage you for the details to come along and talk to me, or talk within the project. So here is the big picture of the Secure World evolution and the Secure Partition Manager evolution. So in 2018, last year, and this is already part of the 2.0 release, we enabled one single partition to run in the secure world and executing UEFI standalone MM services. And this is really based on the MM management mode ARM interface, ARM specification. It's kind of a legacy now because this is evolving. We would have hoped to arrive today at a better stage, but what happened is that we started receiving a lot of different requirements coming from different market segments, as we said earlier. So requirements coming from the edge, requirements coming from networking devices. So this secure partition story is becoming way bigger than expected, requirements coming from mobile. So we took a step back. We are rethinking all the infrastructure. Achin, seated somewhere here, is working heavily on the specification that is still called the SPCI, Secure Partition Client Interface. In the meanwhile, so waiting for the specification to be consolidated, before starting doing the reference implementation, we are preparing the ground with some building blocks, some foundation work on resource description into secure partitions, and as I said, on multiple signing domains. So how can you sign differently partitions using different keys, because maybe they are deployed by different owners, a silicon provider or a BIOS vendor or a third-party software vendor that wants to deploy software in the secure world, and they are obviously signed differently. How you could do that? So we are working on these topics. At some point later on 2019, once the specification will be consolidated, we will also provide the reference implementation. So this will allow scenarios in which multiple EL0 partition will coexist, but it will also be possible to mix and match with EL1 partitions, so with trusted OSs running in the secure world together with other EL0 services. This is obviously will require some modifications on the trusted OS side. So we are working with vendors and with the open source trusted OSs to achieve that. The final goal here, or where the arrow is really pointing, is the ARM 8.4 virtualization extension. So once we will have system in place with secure EL2, at that point you would be able to achieve full isolation assisted by the hardware, and the secure partition manager will have to take care of it. So we'll likely migrate to secure EL2 and take care of all the magic at that stage. And this will enable a whole set of different use cases really from the entire ecosystem. So this is the direction of travel. I put some very small pictures so you won't be able to see them on purpose. So if you want to see the architecture, come and talk to me. What we are really doing is we are creating, you can see that, a migration path. So existing system will be able to implement all of this, and if we do it right, existing system can be easily migrated in the future towards 8.4 systems. Just plug in the Secure EL2 software in the middle with few to none, hopefully, modifications in the secure world software. So that's the migration plan that we are thinking of. And that also explains why we are taking a bit more time to define all of that and arrive to that point. That's it. I'm going to pass the mic to Shabu.
Hi everyone. So Trusted Firmware M was born back in 2018 in another beautiful city, Hong Kong. As we complete a journey of 12 months down the line, we are at another connect in another beautiful city. I would like to take you through some background on Trusted Firmware M, what is it based on, a bit about the journeys and milestones we've achieved over the last 12 months and where we are headed towards. So a bit of background around Trusted Firmware M. It is a reference implementation of ARM platform security architecture. It is a framework that provides a holistic approach to create secure connected devices. It takes a phased approach starting from analyzing your system as a whole to identify the security requirements of the system. Then to put those security requirements or analysis into action, PSA defines a set of hardware and firmware specifications that can be considered as a checklist when SOC vendors are creating hardware, and it acts as a contract between hardware, software, and firmware as you build along the secure device. But that's not enough. In the world where security is getting more and more complex, it's quite important that we also have a high quality open source reference implementation that basically implements those firmware specifications that comes in the second stage and also addresses some of the common IoT threats that gets identified in the analysis stage. So it's the third implementation stage where PSA and TFM coincide. So that's where TFM becomes a reference implementation of PSA. The specifications are all public. The analysis ARM has pushed out a set of common IoT threat modeling and security analysis papers out there. TFM is completely open source. It's part of the trustedfirmware.org community project. The new thing that has happened over the last few months is now it's possible through the PSA certification program to get your implementations certified and tested against. And you can see both of us are not PSA certified, but we are wearing some t-shirts. Yeah. So let's go through the TFM framework at a very high level. So in very simple terms, what TFM is trying to achieve is to create a secure processing environment for ARM v8m devices and for dual core CPUs in the constrained device ecosystem. So to start off with, what TFM provides is a secure boot functionality, which checks for the integrity of the runtime secure and non-secure images. And if you look at the secure processing environment, you've got the TFM core, which is the underlying bit, which has got three basic responsibilities at a very high level. It is responsible for the communication between the non-secure and the secure side. So PSA defines a IPC framework that is responsible for the communication between the non-secure and secure side. The other main functionality of the TFM core is to provide the required isolation. PSA defines 3 levels of isolation, the level 1 isolation being separating the non-secure from the secure side. Level 2 isolation is separating out the root of trust or the TFM core from the secure partition. I'll come on to secure partition next. Then the level 3 isolation is finally having sandboxing between each of the secure partition, which is the highest level of isolation that PSA defines for high robustness. The third responsibility of TFM core is, of course, managing the execution of the secure processing environment. So that involves handling the secure interrupts, secure debug, handling multiple secure contexts. So basically TFM core is at the heart of the secure processing environment, which takes care of the communication, partitioning, and the execution of the secure processing environment. Coming on to secure partition, you can consider it as the secure endpoint of the device you're trying to deploy TFM on. It is a unit of execution which has got a set of related functionalities. So it can be a crypto secure partition or a secure storage secure partition that provides a set of related functionalities, and the non-secure application is able to avail those secure functionality through a standard set of APIs. So secure partition can be attestation or one of the functionalities, which I'll come on when I come to the implementation aspects. One thing to note here is TFM is not probably meant to be used as it is. There is always flexibility to add more secure partitions. So in embedded ecosystem, you can consider that you might want to protect your IP from being exposed to other pieces of software. So it's TFM as a project provides infrastructure to be able to put your own IP or a stack in a particular partition, sandboxing it from rest of the secure processing environment and the non-secure code as well. It's highly configurable, so it's you can either use the TFM core on its own or one of the partitions as in when it depends on the use case you're trying to achieve. So that is the framework as a whole for TFM. So now let's look at what TFM as a project has been doing for the last 12 months. So as I said, it was born 12 months back. And as you can imagine, just like any other baby growing up, it has been trying to grow up in terms of features. It is starting to listen and speak a bit. So you can look at what it has been doing. And it is also trying to make some new friends over the last 12 months. So in terms of growing up, I would like to talk about what features TFM supports today based on the architecture that we just went through. So TFM 1.0 beta was the release tag that was made end of Feb, which supported some of the major functionality that TFM and PSA is trying to achieve. So to start off with, if you consider this as a M33 or M23 V8M core, there's a secure boot today in the TFM project. It is based on the MCU boot open source project. So we have taken a snapshot of MCU boot that is used as the secure boot that verifies the runtime secure TFM image and the non-secure image, which can be any RTOS of your choice. It supports a well-abstracted HAL, so it is quite easy to port TFM into multiple platforms, and we already have got quite a lot of engagement with V8M parts where people have taken the open source project and without a lot of effort ported it into multiple silicon platforms. It has got the TFM core. Today it supports a secure partition manager, which does level 1 isolation, so it separates the non-secure from the secure processing environment. It has got a very basic interrupt handler in place. In terms of services, it supports secure storage today, so this is basically used to store any secrets in the system. So it is based on a very simple file system under which you can store your keys, hashes, certificates, everything. It is exposed to the non-secure side or to other TFM services through a standard PSA API. There's a crypto service which is basically using the embed TLS library. Again, it is exposed to the non-secure side through a standard PSA defined crypto API. And the third service it supports is the attestation service, which is quite important for a IoT endpoint, which tries to connect to something like a cloud. So what the attestation service basically does is it helps the device to authenticate itself as a very genuine device. So from a TFM perspective, what attestation does is it collects a set of claims from the system, munches it together as a token, and it can be relayed back to the non-secure side on the request from a relying party. So if the cloud wants to authenticate your temperature sensor as a genuine device when it comes online, the attestation service can be used to basically collect the set of claims, which includes the hardware unique ID, the secure boot measurement, and a set of claims that TFM defines. It is munched into a single API, which can be relayed back to the API, to the cloud provider. It gets encrypted using the initial attestation key that is stored on the secure side. We have been following something called the EAT, or the Entity Attestation Token Specification, which is a IETF-driven standard way of defining claims for attestation use cases, where it defines a set of claims that can be put in for attestation. It defines a container format called CBOR, and it's encrypted using the COSE format. to generate those attestation tokens. So what this all enabled around February was to use TFM 1.0 beta to enable TFM partners to take their silicon platforms and TFM for the newly launched PSA certification program. So it made quite a lot of noise around the embedded world timeframe. So if you go to psacertified.org, today you will find around 20 to 25 platforms which are PSA level 1 certified. I would say most of them were using TFM as the root of trust. So this involved taking the silicon platform, porting TFM onto it. Level 1 certification involved answering a questionnaire, submitting it to one of the PSA labs, and getting the level 1 certified logo. As part of that, ARM also went for a level 1 certification on its reference platform. So if you go to the site, one of the platforms that is certified today is the Musca B1 platform using the TFM 1.0 beta. So that was a security certification. There is also a functional API certification, which is basically checking for API compliance. So the 3 services that I just showed around storage, attestation, and crypto can be tested for API compliance using a test suite that runs on the non-secure side. So Musca B is also PSA API compliant, and there are a bunch of platforms which you can find on psacertified.org that are today PSA API certified, and they all use TFM to achieve that. So that was more about the growing up and what features it supports today in TFM. But as Matteo was alluding to, Trusted Firmware is all about collaboration and how do we build a community around it. So it's important to have that collaboration going at the same time as building up the features. And we have been quite keen in trustedfirmware.org to facilitate that. So one of the things that got kicked off was a public mailing list for TFM. So there is nothing that is being done under the hood or in a secret manner for Trusted Firmware M development. So any design that is happening in TFM, it is posted in the mailing list. So it gives an opportunity for people to comment on, just like the Linux kernel mailing list, and we can see RTOS vendors, tool vendors, silicon partners, they're all jumping on to some of the design proposals, making their comments with the intention of coming out with a better design. So we kicked off the mailing list around end of October, early November, and I see it as a gradual growth, just like a baby starts uttering words one after the other. So in November, we just had one message going out, probably from ARMS, telling about the mailing list exists and such a design exists. But we could gradually see in this graph that the number of messages has been increasing. So there were around 10 messages when we got to the beginning of 2019. So, but today, if you look at TFM mailing list, if you subscribe to that, there are constant conversations going on around TFM design, build issues, build system issues on a daily basis. And there were around 56 messages in Feb. I was looking at how many messages went through in March. It's around 60 messages. So I think that is a sign that the community engagement is growing up at a rapid pace in TFM. So that's one aspect of the community engagement. The other thing I would like to announce today is TFM is also pushing out an open CI system under the Linaro infrastructure. So from now onwards, it's possible that every patch that gets submitted goes through an open test system using Lava, going through testing with MPS2 to start with, getting back the results, giving a +1 in the TFM get it. So Dean and Ben are actively working on it. The hope is by end of the week, we'll have a open TFM CI system. In addition to that, there's a hacking session on Thursday afternoon from 2 to 3. So please do come along if you want to discuss more about TFM, the architecture, and how do you get engaged more on that. There is also a secure payment demo on Friday showing how it all integrates from a feature perspective. Talking about OpenCI, I was listening to the talk today morning. I don't know how many of you made it to the keynote today talking about open source QA. And I think this builds around that story that we don't want TFM to be tested in isolation at different places. It builds to the stability and long-term maintenance of TFM to have such an open CI, which developers of TFM can use quite transparently to look at how their patches are doing. Is it bringing more stability to the system? What else? So as a kid, I think TFM is also starting to make friends. So TFM is less relevant as a standalone system. It doesn't have a relevance on its own. It has to work with, for example, an operating system to be used by an application. So if you look at the operating system space, so EmbedOS has now got an integration of TFM in the release that was made end of March. RTX already has an integration with TFM. We are actively working in the FreeRTOS and the Sapphire community to have TFM integrated with those RTOSes. Then the whole attempt around standardized APIs, standardized HAL is to sort of make the adoption much more easier for application developers and for platforms to make use of TFM. Tool chains, we started off with GCC and ARM compiler. The IAR team is actively working on enabling TFM using their tool chain. So what's coming? So what I showed in 1.0 beta, I think it's just a starting point. It supports level 1 isolation, 3 secure services, but PSA or TFM is trying to achieve much more than that, what is there in 1.0 beta. So just a preview on what's on its way. So one of the big things that got merged in the last few days is the PSA IPC framework. So that is the PSA defined way of communicating between the non-secure and secure side. The level 2 isolation is actively being worked on. So that is basically having a level of isolation between the root of trust, which is the blue bit, and the secure partition. So even if there is a vulnerability in one of the services, it doesn't affect the privileged or the TFM core domain. Secure boot, we have been working with the MC boot community to enhance secure boot. So there are things like multiple image update and rollback protection, which is actively being worked on. Then there's a piece of work to support the different services in IPC mode as well. So that is ongoing from start of Q2. So all the work so far has been very much focused on V8M core. So systems which has got trust zone in it, where you have got a single core running an RTOS and TFM. But there is also an active engagement under trustedfirmware.org, mainly between ARM and Cypress, I would like to say, where we are trying to run TFM on one of the V6 cores and the OS on the other V7M core. So that's also an enablement which has got to a prototype stage and is hopefully getting stabilized over Q2. Then there are usability features like having a lightweight scheduler on the secure side, supporting preemption to the non-secure side, and all the usability aspects. So TFM becomes much more easier for application developers. Then there's a work piece that's getting kicked off to integrate the secure boot and the runtime crypto to crypto accelerators, which is also a very common use case in the embedded space, where you've got crypto accelerators rather than software crypto libraries for secure boot and runtime crypto. So that was a quick preview on what's coming in the next couple of quarters. So just to wrap it up, so PSA was launched late 2017. TFM, the first version, was launched in a similar connect in Hong Kong. It has been fast growing up. In between, we had the trustedfirmware.org getting announced. The PSA specifications went public. We had the 1.0 beta just in the last quarter. It enabled a lot of platforms to be PSA certified. There's a lot of interest to get to the next level of certification. There's a lot of community engagement through the mailing list. We are pushing out the CI. I think 2019 will see a lot of these TFM features and community engagement going forward. There'll be hopefully a V1.1 or 1.0 of TFM. So the toddler is getting even more naughtier. I think it will start going to school and become a bit more disciplined and more engaged with all its friends. hopefully. So I think it's time to celebrate a bit. So we've got some cake and wine as we're celebrating Trusted Firmware M's first birthday, and I would like all of you to join trustedfirmware.org in that celebration today. And at the same time, feel free to ask any questions depending on what takes priority, whether the cakes or questions take priority. Thanks.